Hello students, welcome to your favorite channel Science with Mukherjee sir. Myself KK Mukherjee. Today we are going to discuss a very important aspect in your chapter, that is classification of elements and periodicity of properties of the element. In this video we are going to discuss the modern periodic law. Then we will going to discuss the long form periodic table, and we will try to correlate this position of the element with the electronic configuration of the atoms of the elements. So let us understand first the modern periodic law. When Mendeleev developed his periodic law and consequent your periodic table, at that time nobody knows about anything inner structure of the atom. Nobody knows about the electron, photon, that is the atomic particles. Nobody knows. In the year 1912, mostly the physicists, the British physicists, found a very good analogies, good similarity in the spectrogram of the X-ray of the element emitted by the element. What he found, when he plot the frequency of the element, frequency of the X-ray emitted by the element with its atomic number, it gives a very good plot. It gives a straight line plot. Whereas when he wants to plot the atomic mass as against the square root of the frequency, it will not going to give such type of straight line. So from this he conclude one thing, that the atomic number is much more fundamental aspect of the atoms of the element, not the atomic mass. And this way he developed the periodic law that is given by the Mendeleev, and he replaced the atomic mass with the atomic number. So we can write the modern periodic law is like this. The properties of the element are the periodic function of their atomic number. So the atomic mass is replaced by the word atomic number, and this is the modern periodic law. You can understand one thing very clear, that this periodic law gives a very good analogy between the 94 naturally occurring elements. And you can see there is a family where the elements is having the similar properties, and this is very much closely related to the electronic outer cell electronic configuration. And with this help of the modern periodic law, there is a development of the long form periodic table. In the long form periodic table, you can observe there is basically 18 groups and 7 periods. 18 groups are basically deals with the grouping of this element which is having the similar properties, and you can see the elements having the similar electronic configuration has been placed in the group, and you can say it is a family. In that family that you can find the properties are same, that is alkyl family, halogen family, chalcogen family. There is a lot of families you can observe here when we are discussing, going to discuss the periodic variation of the properties of the element that you can see. So this group basically accommodate those elements which is having the similar properties, and the trios is basically those have been accommodate those elements which having the different property. So let us understand the periodic table. So we will now going to construct the periodic. So you can see this is the periodic table, and we have to place the element here. In the periodic table you can see there is a group 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then there is a 13 number, 14, 15, 16, 17 and 18, right? And this is a period, 1 number period, 2, 3, then you can see the 4 number period, 5, then 6, 6, and there is a 7 number period. The 7 number period, and in the bottom of the table there is a accommodation of the another set of elements that will be discussed. One, two, three, 4, 5, 6, 7, 8, 9, 10, 11. So the first element that you can see, the most simplest element in the periodic table, that is the hydrogen. Second element in the group number 18, that is the helium. After this, this is the period 1. In the period 1, there is a 2 elements you can see, that is hydrogen and helium, and you can easily able to calculate from the electronic configuration, basically the electronic configuration of the outer shell. That from that you can able to calculate the how many numbers of elements will be placed in any period, that you can able to calculate, and that is basically twice into the number of orbitals to be fitted in that subshell. That is to be understood. So first, in the first two first element period, that you can say hydrogen and helium. There is only 2 elements because there is a one subshell, one is subshell. Here the electron is being put in the one is subshell, and here it is a one is second element is put in the one is subshell. Then you can have in the second group, second period, that you can see lithium. This is the lithium. Lithium, then beryllium, then boron, carbon, nitrogen, oxygen, fluorine, and neon. Observe that is total number of 8 elements. Say in the third period, you can see that is first element is sodium, then magnesium, then aluminum, then silicon, phosphorus, sulfur, chlorine and iron. Again there is 8 elements in the third period. In the fourth period, first element is potassium, then calcium. See here, another set of elements have started in this fourth period, that is a transition metal element. Because 3d orbital is not filled here, so energetically the 4s orbital will be filled. After that, the 3d orbital will be filled, and so there is another set of transition elements has been put in this period, fourth period, that is scandium, titanium, vanadium, chromium, manganese, Fe, cobalt, nickel, copper and zinc. Total 10 elements. 10 elements have been put here. After this, that is germanium, gallium, then arsenic, selenium and boron, and there is a one is the last element, that is the neon noble gas. That is the first element is rubidium, then strontium, then yttrium, zirconium, niobium, molybdenum and technetium. This is another element, that is technetium, and ruthenium, rhodium and palladium and Ag, silver, and then cadmium. This is basically 4d transition element. Now you have the indium, then Sn, then tellurium, Sn, then Sb, antimony, then tellurium, iodine, and this is xenon, Ze, the element. Here you can see total 18 element, and here also in the fourth period also you can see 18 elements. So 8, 18 and 18 elements you can see. In the sixth group, in the sixth period, you can see first element is cesium, Cs. Then second element is barium. Then third element is lanthanum. Here, in this period, you will find there is a total 32 elements. Total 32 elements. And this here 18 elements will be put, and the remaining 14 elements will be put in the bottom of the table, and this is called the lanthanoid. Lanthanoid, and the first element of the lanthanoid series is selenium, then Pr, praseodymium, then Nd, neodymium, then Pm. Pm is promethium. The next element, that is your samarium, is F, samarium. Then this next element, that is your EU, europium. This is not lanthanoid series, europium. Then next element, gadolinium. After this gadolinium, that is your tuberium, Tb, tuherium, Tb, and the next element is your diprosium, then Ho, then another element, that is Er. Okay. Then you have another element, that is C, then helium, then iridium, then helium, then this is Tm, then Yb, ytterbium, and then last one is deuterium. So this is the lanthanide series, and it is your real earth material. Okay. Then after this come hafnium, tantalum, tungsten, then rhodium, then osmium, iridium, platinum, and Au, and last Ag. After this helium, then Pb, then bismuth, then polonium, then At, and after this you can radon. So you will find the 32 elements. Here it is a 14 element, and here it is a 32 elements. Okay. And the next series, the last series, that is the titanium, then rhodium. After this actinoid series, actinium, and here again the 14 elements put in the bottom of the series, that is your actinoid series. Actinoid series, this is lanthanide and this is actinoid. The actinoid, the first element is thorium, then protactinium, Pa, then uranium, then neptunium, then plutonium, then after the plutonium you have the Am, American, then curium. After the curium you will have the another element, that is that you have to see, and after the curium, that is the berkelium. After the californium is Es, then you have filmium, then Md, endulium, then nobelium, and loarcenium. So these are basically the radioactive elements. After this, you can see that after the neptunium, there is a different that is a radioactive. After this loarcenium, again we are coming to the D block element, that is number 1. Yes, Rutherfordium, then Dubnium, then Seaborgium, then your Bohropium, Hessenium, then Mountainium. Then you will find that this is a 103 atomic number, and here 104, 5, 6, 7, 8, and 9. After this 110 UUN. This is basically IUPAC nomenclature of the element. 111 UU. 112 UUB, 113 UU. This name anilium. This is anilium. Then anbalium. Then trium. Then quadrium.
on pentium, then you see on hexium, then then this is 117 on septium, and on this is 118 elements, that is on octium. So these are basically we are concentrated on the IUPAC nomenclature, where the elements having the more 100 and more atomic number that you can able to derive is now named as per IUPAC instructions, that this name will be can able to give. Though that is all the elements that we have discussed here, that is the from hydrogen, we start from this into 180 elements. And now we can see all the elements as we placed here, the lithium, sodium, potassium, rubidium, all are the elements you can see. They are basically having the same properties. Why there is the same property? Because you can see that they are electronic configuration. The lithium has the electronic configuration is outside cell electronic configuration. Because in chemical property you can see the outside cell electronic configuration is much more important, much more vital as compared to inner cell. So outer cell electronic configuration of lithium is 2s1, sodium is, you can see 3s1, potassium is 4s1, then 5s1, that is rubidium, 6s1, and this 7s1. Similarly, you can see the electronic configuration, outer cell electronic configurations of all the elements will be same, and that is why they will be having the similar in the properties. So here you can see they are further in the, that is you can see here there is all the elements, and the elements are basically depend on the electron that is enter, last electron enter in which substance. As per this is also being termed as a block. This is a S block element, this is D block, this is P block, and this is A block element. That we will discuss later on, and that is end of this today's video. And the next video, with the help of this periodic table, we will going to understand the blocking of the elements, how the blocking is being done. And after this video, that we will go for the periodicity. Why it is a periodicity in the elements properties, we will observe the next video. So that is all for this video. Most probably you have liked this video. If you like this video, then you can like it, subscribe it, you can share to your friends, and I am 100% sure that you will be benefit out of this. And that is all for today's video. Next video will come with the next part of this section, that is classification of elements and periodic table. Okay, thank you for watching.